Good evening everyone. Today we are going to do the daily Leetcode challenge of 23 January 2023. That is question number 997. Find the town judge. It is an easy question after so long. And this question is saying, in a town there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. And what is the condition for town judge? If the town judge exists, the town judge trusts nobody. And everybody except the town judge trusts the judge. Okay. So that is what they are saying. And they are saying there is exactly one person that satisfies the properties 1 and 2. There will be only one person which will satisfy the condition of town judge. So what are we given? We are given an array trust where it is having A and B elements in a vector array. What is A trust B? That is what they want to say. And what we have to return? We have to return the label of the town judge if the town judge exists and can be identified, or we return -1 otherwise. So this is what the question is trying to say. So let's move on to the examples and understand it better. So in the first example, what they are saying? They are saying this A element is trusting B. So what they want to say? 1 trusts 2, but 2 doesn't trust anyone. So there are number of people are 2. So 2 minus 1 is equal to 1. So 1 people should trust the town judge according to this condition, and 2 is trusted by 1 and 1 is trusted by no one. So who can be the judge? 2 can be judge because it is trusted by everyone else, and there was two elements. There were two people, so it is trusted by this other people. And 2 doesn't trust anyone, and that is the conditions for town judge. That's why 2 is the answer in this case. Now what we are given? We are given n equal to 3. That means there are 3 people. And 1 trusts 3, okay. 2 also trusts 3, okay. And 3 doesn't trust anyone. So that is the condition. So except for the town judge, how many people should be there? There will be n minus 1. That is 2 people should be there. And town judge should be trusted by these 2 people. So when we draw array or hash map, or you will understand it better in a graph way. But overall it is just a difference of data structure, how you are storing. Okay, but the concept and logic remains same. So what is happening? The 3 is trusted by 1. Okay. Then it is trusted by 2. So it is updated to 2. 2 is trusted by no one. 1 is trusted by no one. And 3 doesn't trust anyone. And n minus 1 is 2. So 3 is the judge in this case. Because 3 doesn't trust anyone and it is trusted by everyone else. Now let's move on to the third example. In the third example, we can see there are 1 trust 3, okay. 2 trust 3, okay. But 3 also trust 1, and that should not be the case. There are 3 people. So n minus 1 is 3 minus 1, that is 2 people. So 2 people should trust the town judge and town judge should not trust anyone. So when we draw the array, we can see 1, 2, 3. And 3 is trusted by 1, yes. And it is also trusted by 2, yes. So we updated it 2. But 2 is trusted by anyone? No. But 1 is trusted by 3. So can 3 be the town judge in this case? No. Because a town judge should not trust anyone. That is the condition mentioned here. He doesn't trust anyone. And everyone trusts town judge. That is the condition. So that's why the answer in this case is -1. So I hope you got a fair idea how to approach this question. Okay. So I hope you can try this question on your own. Please take a minute to try it and then come back to the video. So I hope you have tried the question on your own. So moving on, what can we say? If we have to solve the question, what we can simply do? We can simply make a frequency array and store the values. Yes or no? We can store how many people are trusted by how much? 3 is trusted by 1 initially. Then it is trusted by 2. So we update it to 2. 1 is trusted by 1 people only. So it remains 1. And 2 is trusted by no one. So it remains 0. We have to store how many people trust the judge, and we also have to store how many people the person trust. Yes or no? 3 trust 1 only, but 3 is trusted by 2 people. That's what we have to store. So to approach this, there is a better approach available. Instead of hash map, you can simply think of it as a graph question. If you have heard about graphs, you will know there are two types of graph: directed and undirected. Directed graph are in one direction, undirected graph are bidirectional. So in directed graph, there is a concept of in degree and out degree. What is in degree and out degree? In degree is the number of vertices entering the node, and out degree is number of vertices leaving the node. So suppose in this case here it is 1, it is 2. So 2 is having in degree of 1 and 1 is having in degree of 2. Okay, and 2 is also having 1 out degree because it is sending one node outward, but 1 does not send any node outward, so it is having 0 out degree. So in the question here what we can do, we can simply get an idea that whenever r in degree is n minus 1, we are getting our answer, that is n minus 1, that is 2. When 3 have 2 in degree, that is 2 people trust 3, then it is good. But also we have to check whether 3 trust anybody or not. 3 should not trust anyone. That means out degree for 3 should be 0. Out degree should be 0. So that is what we have to do. So this is the overall approach to approach this question. So I hope now you can try to code it again. Please give it a try. So if you tried coding it, you would have noticed that when what we exactly have to do, we have to make a condition. What can we do? We can simply do what? We will increase our out degree, increase our in degree, and decrease our out degree. We will initialize every one of them 1, 2, and 3 initially with 0. Okay, we have initialized them with 0. Now let's move on. When 1 trusts 3, we will update it to 1. Okay, when 2 trusts 3, we update it to 2. But when 3 trusts 1, we increase its in degree and decrease its out degree. So it becomes 1. So in this case, you will never found n minus 1 trustworthy person. That's why you will get minus 1 as your answer. So that is how you are dealing with the town judge condition. That the judge should not trust anyone and it should be trusted by everyone. That means its in degree should be n minus 1 and out degree should be 0. So this is how you are dealing with this condition, by increasing the in degree and decreasing the out degree. Okay, got it? So let's try to code this now. So let me just zoom it for you. So to code this, what's the first thing we should keep in mind? We have to return minus 1 for any other case when we are not getting the town judge. So we should write it first. Also, we should notice that when we are making this array, what will be its size? It should be n plus 1. Why n plus 1? Why not of n size? Because you also have to store for the last element. As in this case, you was only storing for 1 to 2 relation and 2 to 1 relation. But you also have to store a relation for 3. Yes or no? That is 3 is also storing a relation. That's why you have to make a vector array of n plus 1. So now let's just make a vector of n plus 1 size. Let's name is trusted if you want. N plus 1 size and initialize every element with 0. After that what you have to do, you will simply iterate in our array, and inside that what you will do, you will update our vector. How can you update our vector? You will update our vector like this. What is this 0 and trusted v1 v1 plus plus? What does this indicate? It simply indicate that v is a vector and v0, that is first element, you are decreasing its out degree, and whenever you are adding the second element, that is v1, you are increasing its in degree. Second element in degree is increased and first element out degree is decreased. Okay, so that is what you are doing here. And after, when you are done with this, you will simply iterate in the loop from int I is equal to 1, I less than equal to n, I plus plus. And after this you will simply check if trusted I is equal to n minus 1. That is, whenever we are getting n minus 1, a person is trusted by n minus 1 people, we can return that index. Return that index. That is all you have to do. And we will not get any condition when it is not trusted by anyone, because we are increasing the in degree and decreasing the out degree for such cases. Yes or no? As you saw in this example. So let's try to run this. Yeah, it is running for all cases. Let's submit it. So yes, it is accepted for all the cases. So the time complexity in this case will be, as we are running a loop, we are actually running two loops. So it will be O n plus m time complexity. Then what will be the space complexity? As we are creating a vector of n plus 1 size, you can say space complexity is of O n. So this is the solution for this question. I hope you liked the video. Please like, share and subscribe. Thank you so much for watching. Bye bye.